comes hand in hand with the DevOps approach. And another question, how many of you are using microservices right now in production? Okay, only a very few of you. How many of you want to use microservices? Perfect, that's great. So hopefully this talk will shed some light on, what changes you have to go through. And unfortunately, the list is quite huge, and that's the theme of this talk. But I'll also talk about the benefits that you'll get when you make those changes. Okay, so who am I? I'm Armagan Amcalar. I come from Germany, Berlin. I work at a startup called UNU GmbH, and we're building solutions for the future of mobility, intelligent mobility services, and we have a very cool electric scooter product. I'm also heading a voluntary organization called LongerWorks, which is a software craftsmanship school for women to help them enter the software industry, because there's a huge gender gap, and it's the responsibility of every one of us to fix that problem. I'm also actively authoring a lot of libraries and tools on GitHub, libraries that range from microservices to signal processing to web audio to brain signals and front-end libraries. So if you are into open source, you can take a look at the array of libraries that I have here. All right, let's start with the summary first of what we're going to talk about. The idea is, and all of you just confirmed me, you want to adopt microservices. But the question is, are you really ready for the challenge? It's a huge challenge. It's actually, as Carlos told, it's actually a bigger challenge than adopting Agile over Waterfall. And it's also a huge risk and a huge challenge that you have to be prepared for. And yeah, my talk is about the stuff that you need to keep in mind before you adopt microservices. I want to start with the definition of what is not a microservice, because this is a huge topic of a hype currently, and everybody is talking about, this is microservices. If you use Nginx, it's microservices. If you use Redis, or if you use RabbitMQ, etc., you're doing microservices. No, that's not true. And the asynchronous operations that you have with queues or other systems that don't touch the user, they are not microservices. If you have 50 different queue consumers for notifications, for emails, for invoicing, or any asynchronous operation, you are just doing queue-based systems consumers, and they are not necessarily microservices. Even if you have 50 of them, 100 of them for different purposes, you are still not doing microservices. Even if you're doing multiple programs that communicate over HTTP via REST APIs, it still doesn't necessarily mean that you're doing microservices. You are doing some sort of services, and it may be called service-oriented architecture, maybe, but it's actually far from what microservices are. And then obviously the question is, what is a microservice? And the idea is, if you are breaking down a single client request into multiple smaller requests that are handled by different services, and if they collaborate together on the response that needs to be sent back to the client, then we can say that you are doing microservices. Think about an e-commerce application. Whoever bought something online from the internet? Yeah, perfect. So you click a button called purchase on your cart, on your shopping cart, and then a bunch of stuff happens in the background, and you get a confirmation page, right? What happens is they check your credit card, if it's legit, if you have money on it, they deduce that money, they make an invoice for you, they let the shipment or tracking company know that they have something prepared for you. They obviously check the stock so that the items that you want to buy are actually in stock, that you can buy them, and a bunch of other stuff actually, notifications, etc. And all of these, if all of these succeed, you get a confirmation page. And if some of those break. For example, there is no stock, or you don't have any money on your credit card, then you cannot buy that thing. Now, this is a single request. You just click one single button, and all of these happen, right, in accordance synchronously until you get a response. Now, the idea is previously we were doing this with monoliths, with a single application that took care of every one of these steps. And the idea is if you break down these into different services that live on different servers in their own memory space, then you are doing microservices. So more ideas about what microservices are and what is a better way of defining and using microservices. Anybody familiar with domain-driven design? Domain-driven design. Okay. So it's one of the best ways to do microservices. It's actually one of the best ways to do software design, arguably, but it's a very good architectural technique that you can follow to define what your services should look like, what your models or your classes should do and how they should work. So if you are unfamiliar with domain-driven design, there is a nice book called Domain-Driven Design by Eric Evans from early 2000s. I encourage you to check it out. It really sheds light on how to structure software applications. But it turns out that it's also a very good guide to design microservices. It breaks down the business problem of this purchase thing into stuff called domains. So payment is a domain. Stock management is another domain. Shipments and tracking is another domain. Notifications is actually another domain. And none of these, if you really think about it, none of these have anything in common. They are totally separate. They are separate concerns. So domain-driven design teaches you to break down the whole scenario of a purchase into these separate blocks and separate workflows, basically. And it turns out that it's a very good way to separate your microservices. And there's a concept called bounded contexts in domain-driven design, which is a group of domains. And in the worst case, your microservices should reflect the bounded contexts in your application. Usually, a usual size of a real production or professional application has around 100 microservices. And like if you have 5 or 10 microservices, then you're probably not really using microservices. There's a reason that's called micro. But another benefit is distributed computing, which means if there is a problem in one of your services, let's say shipment, the rest of your system is online. So people can still buy stuff, they can still visit your store and your categories and items and everything you have on your site except shipment, which is just only one workflow. Which means if there's a bug there or if there is some downtime, it doesn't fail your application. It's just a single workflow, and well, hopefully you have some automated services to fix that problem and to replace that. Therefore, it scales really, really well. Beforehand, you had to replicate your servers, duplicate them, and scale your whole application. But now you can individually scale the services that cause you any trouble. Therefore, it brings you huge benefits in terms of bringing the cost of maintaining your application down. Another benefit is the event-driven architecture. How many of you use event-driven programming? Okay. It is a good way to decouple services, to reduce coupling between services so that you don't know much about concrete implementations of classes in another domain. So you just pass an event, which is kind of a string, and then some arguments. And yeah, microservices is also very, very suitable for that because it's API driven. And a better thing is you have single responsibility in each service. They only work for what they are designed to do. So if you saw any raw SQL queries in your views, for example, or in your controllers in your web application, it's completely wrong. They should belong to a layer of business logic that is below views or controllers. And if you're doing payments and you have to also issue an invoice or a letter to the customer, that's not your concern. That is someone else's concern. So you shouldn't be doing raw queries or accessing the libraries of that invoicing feature yourself. And well, that gives you single responsibility. So you look at a piece of code and if you're dealing with payment, you know that it only deals with payment. And when you take it out of the system, nobody has anything to do with payment other than you. So nobody is actually messing with your tables, with your columns, or with your databases, or with your libraries. So you are actually free to change your payment service however you like. And another benefit is a clear API interface. So everything you use, every communication between services is actually defined in an API documentation. Okay, the best practices of microservices. This is actually the topic of another talk, so I will just briefly mention them. But you have to clearly define your interfaces, your API interfaces. It can be a REST API, it can be SOAP or any other thing. Hopefully not SOAP. Anybody using SOAP services? Okay, hopefully it's not SOAP. It was a nightmare. But the idea is your microservices should automatically discover each other. They shouldn't require any configuration at all. So if you remember, writing or keeping track of IP addresses and port numbers or host names of your servers, those days are over. In order to adapt to microservices, you just kill that. So your service has to be highly available. It cannot fail. And the idea is you should be able to scale or update or make a new build for every single service. And there's another approach called favoring kettle over pets. Anybody heard that before? Favoring kettle over pets. All right, you should have known that. We covered this topic yesterday in the workshop. Favoring kettle over pets is actually what defines DevOps. So pets are animals that you call by name, that you care, right? You have a cat or a dog and you care for them. They are your family. And cattle is like a herd of sheep or cows. You just care about the number and you use them for production, for milk, for meat, whatever. And if one dies, well, that's a pity, that's a shame, but you just replace them with another one to keep the level of production the same. So you don't really take individual care of them. And frankly, sometimes you just put them in cages. And this is how you should treat your servers. If you know your servers by name, and infrastructure guys or operations guys or system administrators love to give unique names and funny names to their server. If you're doing that, then you're not doing DevOps or microservices. You shouldn't care about your machines. You shouldn't have SSH access to the machines. Everything should be automated. You shouldn't even know which service is running on what machine. All right, the pitfalls of microservices. The biggest problem is you may start with the wrong domain model, which means you cannot find the right boundaries between your microservices. And sometimes your microservice has to do more than you designed it for. Like you may find yourself writing invoicing code in a payments microservice. Error handling and circuit breaking are really, really hard. Because beforehand, when the server crashed, you exactly had a stack trace, right? How did you come to that point of crash? In microservices, there is nothing called a stack trace. Well, there is in individual services, but there is no way to track that request through that service. It requires heavy monitoring. And it also requires that your systems should be fault tolerant because they will crash, they will rapidly crash. And you have to make sure the rest of your system is unaffected by that. This also gives you multiple points of failure your application can break in multiple systems and multiple services, and it's really hard to keep track of them. And another pitfall is you have so many details, so many different moving parts, it's really hard to focus on the big picture. You cannot see the big picture. You cannot see the forest because of the trees. So it's hard to imagine the whole chain of command and responsibility in microservices. But okay, in the morning, Carlos talked about change. It is the essence of the game. You have to embrace change. And he told that rightfully, we developers don't really want change, or system administrators. We want things to be stable and not change over time. But everything will change when you want to adopt microservices. Code will rapidly change. Release cycles will be in days or hours, so you can't keep track of the change set, the release change set. People will rapidly rewrite their services because each microservice is at most around 1,000 lines of code, and it's a very clear API. So actually you can redefine that microservice or rewrite it in another language or in another setting. So it will rapidly change, and it's really hard to keep track of what everybody is doing. The dependencies between individual services are clearer now, and you break them down into silos of functionality, and that means you make the dependencies more clear, and every service depends on 5 or 6 other services, APIs, and it's hard to make sure when somebody deploys a new version of the payment service that the invoicing service is actually compatible with that. So backwards compatibility becomes a huge issue. Dependencies will change daily because there is no single release to production button, and everybody is releasing on their own schedule. Every team and every microservice gets released whenever it's ready for the next update. You have to make sure the backwards compatibility is there. And deployment and release processes will change. So there is no single person responsible for giving a go for the whole application for the next version. If you have 100 different services, basically there is no coordination even. They will just deploy to production whenever they think they are ready. Therefore, you have to have continuous integration and continuous deployment, and you have to automate every single step, including testing. So the idea is, how can you adapt? I will talk about some changes that are required in order to adapt microservices and DevOps. The first one is mindset changes. So you have to look through another window in order to adapt to microservices. You have to own the change. You have to give away responsibilities. If you're leading a team, or if you are responsible for the infrastructure or administration, you have to defer the responsibilities. Now the developers own their own services. And another problem is, as I talked before, the visibility on dependencies. Beforehand, you really didn't know which parts of your application is calling what model or are doing what raw SQL queries. It's really hard to prevent that. But now everything is visible. Everything is on the table. So you have to adapt to this increased visibility, and which means you have to make them visible architecturally as well. Anybody doing architecture documents like class diagrams, sequence diagrams, component diagrams? Okay, a few of you. And anybody knows UML, a language for making these graphs? That's great. So those graphs, they are back. There are actually really nice tools to design UML graphs. You don't have to draw them. You can write code and generate those graphs, which a tool is called PlantUML, if you know it. That's really nice. But the idea is all those architectural documents are back, and they are more important than ever. You have to document your system because you have 100 different moving parts. You have to know which service is communicating to whom and what is the clear API between those services. So in the morning, Carlos said the role of the software architect is shrinking. it was with Agile until we were doing microservices. Now it takes a huge challenge to design the right interfaces between different services. And you have to document them very, very well, clearly. You're not documenting the class implementation details, but you're documenting the communication between different services. And believe me, it's a huge mess. It's really, really hard. So you have to embrace DevOps as well. And another part is testing. I already mentioned that you have to automate all the testing you can. And who is doing unit tests? Okay, and who is doing end-to-end tests? Yeah, the same amount of people. All right, so there's a controversial topic in adapting microservices because you have finite time. You cannot write tests in every scenario for everything from unit tests to end-to-end tests. But the idea is, since you have different moving parts, unit tests actually don't give you much value. Even if one single service works correctly, it doesn't mean that they will work correctly when combined with 20 different services that depend on your service. Therefore, you have to increase the automated user acceptance testing, which means, maybe you write Selenium scripts for your web applications, or you write some code to test your APIs, your endpoints to the outer world. But the idea is you have to test the communication between your microservices so that your end users, for your end users, the application works as it is designed. It's really important. And for example, right now in my company, we don't do unit testing at all because the benefit you get from unit testing is relatively small with respect to user acceptance testing, which ends the whole system from end to end. I don't individually care. I don't care if individual microservices are wrong. I care if the API works correctly and delivers me the results that I want. And if one of those services don't work or don't work as well as designed, that's not a huge problem, really, as long as the APIs are clear. So the benefits that you get out of this is an increase in code ownership. It's one of the biggest problems in team management. Your developers don't really care about the code they write or the features that you deliver, and you always try to boost their motivation or responsibility or ownership in your organization. You try to make them aware of their impact on the lives of your customers, which is really hard. But if you actually adopt microservices, these things come alongside that, because I will talk in the near future, but people become responsible for single features and single services. So there's no, I did my part, but the backend guy delivered the wrong API. Or I did my part, but the database wasn't working. Or the infrastructure doesn't really handle this, this load. Basically, people start owning features instead of pieces of code. Therefore, it leads to better performance in your teams. Everything is automated, and developers can check on their machines if their environment, if their microservices will work on production. Therefore, there is no stress. The idea that it works on my machine is finally true. If it works on the developer's machine, it is guaranteed to work in production. Therefore, there is no stress about deployment or releases. Architecture is very straightforward. You clearly see the dependencies, and you can clearly refactor when you see some dependencies are just wrong, that you made a mistake in your architecture, which reduces technical debt. Anybody familiar with the concept of technical debt? Cool. Well, it is the biggest concern for legacy applications, and a good way to prevent it is to have individual services to be rewritten really simply, and microservices give you that. And yeah, I already talked about domain-driven design. So the infrastructural changes that you have to implement or adapt to in your organization. Previously, applications used a single language, right? They used a single environment. we are doing our application in Java or in C# or whatever, and basically you cannot change. Once you go down a path, once you make a technology choice, you cannot change it because it will cost you millions of money, whatever. But the idea that comes with microservices is now you are free to use the best tool for the job. If you're writing invoices or if you're writing payment, you can use whatever language you think or whatever framework or database you think is suitable for that job. If you're using notifications, you can use another database and another language, which is a throwaway language. Or if you find out that your technology choice was wrong, you can actually rewrite it, that service, within another technology, because the API interface is very clear, right? There is no magic going on there. Therefore, you have to give this autonomy to your teams to use the best tool for the job. This also comes with another maybe pitfall. You have to invest in a solid continuous integration and continuous development process. It's really hard, I know. And most of you are currently releasing to production by hand right now. You cannot manage that in microservices. You cannot see a big picture of 100 services. You have to make sure that they can be individually deployed to production. You should be using pipeline builds for testing, for deployment, with several stages for integration environments, etc. And you should be using containerization technology. Anybody not using Docker or any container system? Okay, so which means you manually manage your servers and deployments with pushing the code to your server and then bringing it up. The idea is containerization gives you that immutable environment, and if it works on the developer's machine within containers, it is guaranteed to work in production. So you have to introduce containerization as a first-class citizen in your development process. Your developers shouldn't be running the code, your application, bare bone on their developer machines. They should be running in Docker, in a container, even in their own development machines. They should be debugging within that container just to make sure that it runs the same in production. And you have to heavily invest in monitoring because, again, you don't have stack traces. You don't know what service is causing trouble. And you have a couple of servers, like maybe 10, 20 of them, the smallest servers in any cloud provider. And you have to invest heavily in monitoring to be able to combat that. But the benefit is there is no vendor lock-in. You don't have to use a single library or a single solution now because these services are really tiny and small. And if you think that you started paying more than you should to a cloud provider or a proprietary library, you can just throw them away because there is no vendor lock-in. You can rewrite that piece. There is no secret sauce. There is no magic or every single request that is coming to your piece of source code, which is your microservice, is clearly defined. Everything is on the table. There are no surprises that can happen in your system. And you can migrate really easily to another cloud provider, to another language. Actually, we have fully automated our build pipeline and development and deployment, and we don't use any of cloud tools. We're currently running on AWS, but previously we were running on DigitalOcean. And we migrated our production system from DigitalOcean to AWS in about 10 minutes with a single command. So this is zero vendor lock-in. And this is actually really simple if you adapt all of these automation tools. So all you do is reduce the number of servers in DigitalOcean, increase the number of servers in AWS, and your automation takes care of migrating everything. Obviously, databases are a challenge, but that's another topic. And the idea is adopting new technologies is lightning fast. You don't have to use languages from 30 years ago if you start doing microservices. Because again, whenever you feel that there is a better technology to solve your problem, you can just throw away your microservice and rewrite it from scratch. Again, because the testing, automated testing is there, the API interface is very clear. And the last point is the organizational changes. This is the hardest. This is about people. This is about team communication and managing the teams and managing the expectations of managers. So most of us are developers here, and you know, managers want to manage. They love to micromanage even. They love to know what you're doing all the time. But it is impossible in the world of microservices and DevOps. Basically, they need to let the teams free. And anybody using Scrum here or Agile? Okay, so you probably, like a Scrum team usually consists of a back-end engineer, a front-end engineer, a product owner, or something like that, right? And there is constant collaboration between, or fights between back-ends and front-end engineer who says, you know, I want that API. No, I cannot give you that. You have to use this. So it's always a constant fight where the business logic implementation will happen. But the idea with microservices is now people will own everything for a feature. Are you adding a field to your invoices? A person or a team will be responsible for that very small feature for all their lives at your company. So it's their own. Like, they did the technology choice, they designed the API, they implemented it on the back end in the database, they deploy that code to production, they wrote the code that, you know, pushes their service to production. They have the ownership of that piece of feature. So your Scrum teams will shift to a group of people who resemble actually your microservices architecture. So probably each microservice will get a team, and that is the responsibility of that team to work. And since the API is quite clear, collaboration is really easy. One problem for managers is the problem of hierarchy. They love to manage. Again, they love hierarchy. They love to dictate. But with microservices, actually the teams are kind of autonomous. They make their own choices. So you cannot, when you have 100 different services, you cannot judge the team for making a choice for that microservice. You can monitor its performance and you can warn them, hey, like this doesn't conform to our expectations. So can you improve that? But it is their responsibility. So there is no hierarchy that says, no, you have to implement it that way. This is the language that we're using. This is the database that we're using. There's nothing like that. Which brings another problem. This is a real problem for organizations. The consistent vision. So when you have a dictator at the top, it's really easy to enforce a vision, a consistent way of doing stuff, let's say at least. And when you have autonomous parts, autonomous teams which are doing individual microservices, I already told you that you sometimes lose the big picture. You have to have a way of making sure the teams conform to non-functional requirements. It may be latency, it may be, you know, the time it takes any piece of code to be released to production, or any other way, you know, code style or approaches or architecture, like applying domain-driven design or agreeing on a set of design patterns to do software infrastructure or software architecture. So you should find ways to define your vision and your culture, your engineering culture, and you should document these. Because it's not obvious. Some team is using Scala, another team is using JavaScript, some team is using Python, some team is using PostgreSQL, another team is using MongoDB. And how do you make sure they are on the same level? It's really hard for managers, and I myself am struggling with this from time to time. But the idea is there is constant improvement. If we find any blind spot, we are free to change it immediately. So the benefits, agility. Instead of 2-week sprints, you do daily releases or hourly releases. Whenever the code is ready, you just push to production. And you don't care because you know, you're confident that it works. You have smaller teams, so you have easier decisions. You don't have fights between different organizations to define an API. And who has in their teams a situation like, oh, I will do my work, but this guy is blocking me because he didn't deliver this. This is a constant pain in teams, right? Because you are trying to deliver a feature, but apparently that responsibility is also shared within another team. You cannot deliver with this setup. But if you're applying microservices, you are responsible for a single feature, and there's no one else. There's no one else to blame. And when you remove the blaming culture, then you can actually talk about delivering value to your customers and to your company. This basically leads to more happiness, more ownership in your teams, which is, something that every company should be looking out for. It comes with productivity, and this is really suitable for remote teams, for distributed teams. You can now say, I have 100 services, 30 of them are developed by these distributed teams all over the world, and a single microservice is done in this country, another one is done in this country for this team. It's really easier to manage when the dependencies are clear. All right, the conclusion is microservices and DevOps will actually supercharge your organization, and I hope I could convince you to convince your managers to adopt microservices. The future is really bright. The future of software delivery and software development is really bright, and the game is afoot. Thank you. Basically, you don't have data integrity. There are no transactions. Everything is distributed. There is a concept called eventual consistency, because you are relying on caches and remote calls every time for every piece of data. You know that eventually, in a couple of minutes, or maybe sometimes in a couple of days, the data will be consistent. But for now, it may not be consistent. So you have to design around this, and if you need transactions, you have to think through if you really need them. You really need transactions when doing payments, and outside payments, I found that most of the problems that you think you need transactions are actually can be solved in other ways, and for payment data or similar mission critical applications, you have to design your own transactional system. It's really hard.
Hi.
Hey.
I have a question. I actually have two questions, but let's start with which methodology is the best one to use in such teams? As you said, scale can go up to 100 microservices.
Yeah.
Then, what about people managing these services leaving the company, and what about the technologies that are getting older, which were implemented in these services?
Yeah.
And at the end, how to resolve conflicts in priority between two APIs or between front-end and back-end when there is a change?
So if we're talking about project management methodology, you cannot use waterfall, obviously. You cannot even use agile. There is something called lean development or lean architecture or lean startup, which only works with a priority list of to-do items, and you are only allowed to tackle the first item in the priority list, and that priority list is defined by a product manager. And then basically you take that card into in progress, and then you work on it and deliver it, and ideally this time is under a week. So in a few days you should be able to complete a card and push it to production. And you are constantly going to production anyway. There is no release management. Or there's nobody controlling those releases, so everything should be automated. So whenever you're done with a task, whenever it's tested, even if you have human QA engineers, you are constantly pushing to production. So I hope that answers the methodology question. And the other one is about all technologies, or what happens when somebody leaves the company. The good thing is you have architectural documents. So no piece of code is hidden, actually. Well, individual implementation might be hidden, and if you don't like the weird technology choice that employee chose for that microservice, you have the API footprint anyway. You can rewrite it in another language. It's really small. Again, it has to be under 1,000 lines of code, and that's even too much for a microservice. You may have to break it even into further services. So if somebody leaves, you have documentation, and you can rewrite it really easily. That also answers the old technology problem. You can use whatever new cool technology you want, and yeah, maybe that's it. And the conflicts between front and back end, it doesn't happen because ideally a person is responsible for the whole stack, even on the front end, which is really hard to get. Please.
Thank you for the speech. I have two questions.
Yeah.
First, about front end and back end teams. If you split monolith enterprise application to front end, back end, and you have a problem with employees communication, and front end ask APIs, back end say no, no, no.
Mm-hmm.
If you split monolith application to 100 of microservices, and you have 100 problems between
Yes.
microservices.
Yeah.
What do you do with it?
So that is where the vision comes into place. Everybody should know how to design a microservice that will fit into your ecosystem. And it's a culture that you have to implement. It's hard to get. It will not happen overnight, and you will have a lot of problems before you can, be this productive. But once you have it, then it will be super smooth. Basically, like we spend maybe 3-4 months to adapt to an idea of microservices, and now there is zero conflicts between teams, even if they contribute to a single client request over multiple microservices, which means multiple teams. It's a lot smoother when you have a vision and a clear guideline on how to implement microservices, but it's really hard to get.
Second question about documentation. If you wrote architectural documents and deploy the microservices, and this document stay not correctly.
Yeah,
in the
stale
line.
documents and updating documents, basically there is no compromise.
You have a special architecture team who
No.
all time updated.
No, we have some software architects who are responsible for the overall architecture, but individual teams decide on how they want to do stuff. And the guys just make sure that everything is in accordance with the vision. And there is no compromise on architectural documents. You have to update them. There is special time that is set aside for making sure the documents are up to date. But it really pays off really well.
Who checked the correct document?
The architects.
Hello, Nikolai from Flatstone. I have a question. Actually, you mentioned views that they are not microservices. So is there a place for a service bus in that case?
Yes, but it's actually discouraged because it's a single dependency where every other service depends on. And what happens when you lose that? It's too much dependency. Microservices is all about breaking out dependencies and autonomy in features themselves. So it's discouraged, but a lot of teams use that, at least for some small amount of services. So there are event buses, minuscule event buses between groups of services.
And actually, how will you reduce the number of dependencies between microservices? Are there some layers or different groups of them so that big components of big systems collaborate?
So how do you reduce the complexity of microservices? It's an architectural work. You rewrite a lot of stuff all the time, actually. You redesign the responsibilities between services until they are right. But since they are very small, it's easier. And then you have some gateways or the APIs of individual feature group of microservices. So you have clusters of different microservices, and there are some brokers of microservices before those groups to interact with the other systems. So like for payment, you may have 20 services, but in front of them you have 1 or 2 services to be the interface to the rest of the system.
Thank you.
Thank you, Armagan.
Yeah.
Please allow me to give you a present.
Oh, thank you. Thank you very much.
Unfortunately, we don't have any more time for questions. If you have any questions, please ask our speaker in the hall.
Yeah, I'll be around for a couple of more minutes. Thanks a lot.